screen that you guys are not on, but it's now not showing. This is awesome. It's not showing me any of the recording tools. So um, let's see what's going on here. Well, we'll just run with it and see how she goes. And then, oh, now it's showing up on that screen. Weird. So then I will present a window, that window, share. Okay, so hopefully it's coming up. I have a two monitor setup here, so I will be looking that way, not at the camera for a good chunk of this, just so you know. Hopefully right now you're seeing the, dang, this is annoying. Hopefully you're seeing the lesson plan sort of stuff over here. So we'll go through that way. All right. So I will put the recording of the session here. I think I'm going to also put in like Google Classroom, and you can have topics, right? Like on the classwork tab, then there are these different topics today, general resources, electric fields. I'll put in the general resources, I'll put in a link that just has all of the recordings, or at least that's my plan. So you can check there for all of the daily recordings. Recordings that are for a specific assignment will probably just be stuck in with those assignments. And then due dates, notes, recorded videos. I just addressed the recorded videos. With due dates, it was in the Google form, but I just want to make sure you're aware that when I put those due dates in for assignments in Google Classroom, that's really, I'm putting those as due dates just to make sure that you have a feeling for like how to stay on track. Like if I get this done by this time, everything should be okay, and I shouldn't be falling behind. If something happens, and things happen, if something happens and you can't get an assignment turned in by that due date, you know, hey, work on it, get her done later, and turn it in. You'll get credit. Life will be good. That's not in any way like a turn it in by now or by gosh, by golly, I'll be after you. It's just like it's a guideline, right? Just trying to keep things reasonable for that. Notes, we have a little bit of a reference to notes today. I'm not going to ask you to turn those in because it just kind of seems silly. I mean, I'm giving you an electronic version of notes, like copy paste them and show me that. That seems stupid. Um, Handwriting, I'll give you a little bit of friendly advice. Handwriting does help write those things down. Your brain processes them differently, thinking about what you need to kind of consolidate. So if you handwrite your notes, that does help you remember those things. I'm not going to require it. I'm just a friendly suggestion that does help. So I'm not requiring you to write them down or to retype them or to copy paste them. But we'll go through and spend a little bit of time on notes. And I, again, will not be collecting them. It'll be some things that'll just generally help. So this quarter we'll basically be doing electric charges, positive charges, negative charges, some neutral things. We'll talk about electricity and circuits. And we'll end with some magnetism and some forces with magnetism and how like 95% of the electrical energy in the world is produced. We'll talk about that, which is all comes down to one method. Then I have the Pivot Interactives assignment here. Actually, we'll do the note stuff first, and then we'll see if we can get to the Pivot Interactives thing, and we'll see what we can do from there. All right, there we go. So the BitO notes, shoot, if I was a smart guy, I would have already had them opened here. I had to move things around a wee bit. So notes, clickety clickety. So these are the slides for the notes. Hoping you guys can see what I'm doing. So these are the slides for notes. This is like in the before days, this is what we would use. Just I would print that out, give everybody a copy, and you would have a spot to write things down. Again, I'm not requiring you to print that out and write those things down. It's, again, just like a reference for how we would normally take notes on things. And in addition to that, whatever notes on there I expect you to have, we will discuss and do in class. So if when we're done, there's like a blank spot or something like that, you do not need to go out and search for that on the internet. You can send me an email and ask if you would like, hey, I don't have this. Did I miss it? Or did you forget to do this? Or are we not doing it? Or however you want to phrase it, you know. But if there's a blank spot in the note sheet, don't in any way feel like you need to start going on the internet and try to find all those things. We'll try to take care of all that stuff person to person. So, click it. Um, let's see. It's taken a while. We're getting there. Okay. So before we go too far into this slideshow, I'm going to start things off a smidge bit with periodic table stuff. And there it is. We'll do this one. Come on. Open image in a new tab. So much better. Okay, so the periodic table of elements, you've maybe discussed this in some previous science classes. Um, there are different ways to talk about the types of substances that exist. Some people will talk about atoms or elements, or those are very similar, very related as pure substances. Some people will then also talk about compounds and molecules. Those are a little bit different from elements. Compounds are when you have a couple of different elements, a couple of different things of these like stuck together, bonded together. If you look on a periodic table, those elements are the things that we can combine and rearrange to make stuff in the world. Um, we've got around like 103 or so. This periodic table here shows 103 different elements. The yellow ones on this are generally considered to be metals. The green ones are generally considered to be non-metals. Like you don't think of neon gas or fluorine gas or nitrogen as a metal. The yellow things are metals. Then these like light blue ones, this thing calls metalloids. They're kind of tweeners. They have some properties that are kind of like metals, some properties that are kind of like non-metals. A little bit of both. But when we look at these things and we start to talk about electricity and charges and things like that, it's kind of helpful to go back and think about atoms. So an atom is kind of a pure substance. It's still made of stuff, but it's a pure substance. So if we go here, this is just a simulation. I did link it in the Google Classroom page for notes. So if we go here and we say, hey, I'm going to make a hydrogen atom. A hydrogen atom has one proton, one positively charged proton in the middle, and one negatively charged electron kind of zooming around outside. There are a couple of different ways to look at the structure for these things. One way that's like very much simplified, but it works as a simplification. We just need to kind of remember it's simplified. One way to think is that these electrons kind of orbit like planets around the sun. That's not what they do, but it is close enough to kind of get a feeling for how things behave. If we add another proton, now we're into helium. Helium usually likes a couple of neutrons. Neutrons have no charge at all. Their presence or lack of presence affects how long that nucleus can stay together. If you really bugger things up and you throw a crap ton of neutrons in there, that might not stay like that and it would become something else. We don't need to worry about that, really. I'm just sharing that with you so you don't wonder why I threw two neutrons in there. So two protons, these two positively charged things, if there are two protons, then it's helium. If there are not two protons, well, it's not helium. We can add another electron, and we have those two electrons in that first kind of orbit level for helium. The way that electrons are a little bit better way to describe them is that the things that are electrons or that we consider them to be tend to exist in an area. They'll call them a cloud, like you see here. So the electrons tend to exist around the center where the protons and neutrons are. But if we think about the structure of an atom like this, then that helps us realize how some of the things work for our next step. So this, I'm not going to ask you a lot about the structure of the atom or maybe even anything about the structure of the atom, but having a feeling for this will help us answer some questions or think about some things in the future. If we remember that protons, the positive charges are in the middle, and electrons, the negative charges are outside, then we can start to think, hey, if I need to move some charges, if I need to grab one and move it and put it someplace else, which one's easier to grab? Well, electrons are on the outside. Easier to grab an electron from the outside and yank that bugger away. Little break, take a breather. I'm checking the chat in the Google Classroom thingy, or pardon me, in the Google Meet thingy, and I'm not seeing any questions, so I'm hoping that means things are okay. Now we'll move on to the slides and just take a look at some of the slides. Terms, definitions for slides. So, all right. So a charge, when we talk about a definition for a charge, it's there are some things that are just easier to say what they do and how they behave. And charge is one of those things where we talk about them much more in terms of what they do and how they behave than what they are. What is a charge? It's tough to say. Like, what is money? Usually, the kids, when I ask questions, what is money, will often get somebody will say it's currency. Okay, what's currency? Or people will give an example. Money is like $1, or cash, or whatever. And then after we get to those, then it's like, well, but what is money? Well, it's something you trade for stuff. I can trade money for other goods, and we describe money in those ways. We're describing money as in terms of what it does, like what we can do with it. Charges are the same way. We talk about charges as what they do, and like charges repel, opposite charges attract. Charge is a characteristic or a property of a substance. If we were going to go through and do calculations with charges or have an equation that used a charge in it, the symbol for a charge, like we use F, a big capital F for force, well, the symbol for charge is a Q, either a capital Q or a lowercase q. Either way works as a symbol for charge. Charge is measured in something called coulombs, and it's spelled funky. That's off of a person's name. So there you go. And then when we talk about protons, protons are small and they have a positive charge. And we usually think about them as being in the center of an atom. They're usually pretty stationary, they don't move. Like in the previous thing that we talked about, protons and neutrons are in the nucleus, the electrons are outside, and the nucleus is just a name for the middle. There's not like a building there or anything, right? So protons and neutrons are here, and then the electrons are outside. And since the protons and neutrons are in the middle, if the whole atom moves, like if you pick the entire substance up and move, well, then the whole thing will move, right? But in general, they might kind of a little shaky bakey sort of a thing, but they're not going to be, excuse me, you wouldn't take a proton out from the middle and put that proton someplace else. Usually what would happen is we take the electrons out. If we remove the protons and things, then that becomes more like nuclear stuff, which is a big deal. And the symbol for charges is Q for a proton or a positive charge. We will usually go with like a plus Q or a Q with a little subscript, like written below sub P. And again, measured in coulombs. All charges measured in coulombs. Electrons, they're small, they're negatively charged. They're on the outside of atoms. They're the things that move. Like if we have things conducting electricity, generally speaking, with wires, it's electrons that are moving. We will say for a symbol for them, it'll either be like negative Q or Q with a little script written below the line, a little subscript, E for electron. Again, measured in coulombs. Give you a little breath there to make sure we have that. Bloop. Okay. And then this again is looking at atoms. We kind of did a little bit of that on that simulation. So an atom has protons in the middle. We call that center spot the nucleus. But again, there's no building there. There's no little, I don't know, plastic housing or anything, right? I mean, it's just wherever the protons and neutrons are, we call that location. Them being there makes that the nucleus. We won't worry about neutrons much. We'll really just say, hey, protons are in the middle, in the center. Electrons exist around the outside. Um, if and then you've maybe heard in previous science classes that an atom is mostly empty space. To give you a feeling for what we mean by that, if a proton was made to be as big as a marble, if we imagined a proton being the size of a marble, that electron, if we had hydrogen with one proton, one electron, that one electron would be an entire football field away. So there's a lot of empty space there. And in between those two things, there wouldn't be any air because air is made of atoms, right? There wouldn't be any dust because dust is made of atoms. There'd be nothing in between, no physical objects in between the electron and the proton that are a football field away, if we imagined a proton to be the size of a marble. And to me, I think that that's kind of like, holy crap, yeah, it is mostly empty space. There are two things, and there you go. And that electron, that would be a football field away. It's moving all the time, and it's in a bunch of different spots, and it's really tough to figure out exactly where it is. I'm going to keep on going unless I see somebody post a question there. I'm hoping to get to a spot within the next 10 minutes where we can go then and take a look at the lab activity and pivot interactives too. So if you have questions or if you're wondering what I said or if something doesn't make sense, please type something up in the chat. Okay. And then we cannot create charge. Like the universe behaves in unique and weird ways, but generally speaking, for all of the activities that we're doing, charge cannot be created. It cannot be made into existence or be deleted from existence. All we can do is move charge from one spot to another. So we talk about here charge by friction, like electron sandpaper. I didn't. There, here. Okay, so I've got just like a plastic from a whiteboard dry erase marker, and then plastic baggy plastic, yeah? So right now, if we think of these things as both being neutral, if we rub one with the other, and generally it works with like PVC plastic and plastic bag plastic, if we rub one with the other, eventually what ends up happening is we basically sand electrons off of one substance and onto the other. When this was first done, people didn't know what charge was being moved. Was it positive charges? Was it negative charges? It took a bit to kind of get some things figured out. But now we've come to realize that it's really the electrons that move from one thing to the other. So if this is the thing that removes electrons, then we're taking electrons off of the marker and putting them on the bag. So that would make the bag more negative because it's got more negative charges. This would then become more positive because if it started off neutral, we'll just choose an easy number. If this started off with 10 positives and 10 negatives, now it's really like 10 gajillion of each, but if this started off with 10 positives and 10 negatives, and then we sand these things away, then the electrons, as they get sanded off of here and they go to here, this would then end up with maybe 10 protons and 7 electrons. And this would have gained those 3 electrons. This would have a negative total charge overall. It would have positives and negatives, but the total would be negative because it stole some from here or sanded some off of there. If this started off as neutral and then had electrons sanded off, it would end up being positive because it lost electrons to the sandpaper. I hope that makes sense. So one way to transfer charge is by friction, like that. Another way is by contact. And so if we go to these first two and we kind of combine them, Sometimes at your house or at your parents, grandparents, aunts, uncles, the neighbors, whatever. Sometimes you go to a friend's house or your house, your home. If you run across or as you rub your stocking feet across the carpet, you might build up a charge, and then you touch the cat or your sibling, brother, sister, mom, dad. You touch somebody and you get that little spark. Yeah. Well, the rubbing of your feet across the carpet would be like the friction and electron sandpaper. Then touching somebody and zapping them would be charging by contact. Or in the winter, you're sitting in the car and you're moving along, you bounce a little bit, and your jacket is rubbing back and forth against the seat and your back, and you get a charge by friction there. And then when you get up, maybe you grab the door or something, and there's charge by conduction and contact there, transferring that charge. Induction is another thing. It's really kind of cool, but we won't worry about that right now. Um, and we kind of talked about that there. Objects that lose electrons now have more positives than negatives. Objects that gain electrons now have more negatives than positives. At the electroscope, I forgot to get that out here. We'll show you that another day. All right. Okay. Then, and that stuff I think we'll hold off on until another day as well. So tomorrow we don't meet, but I'm going to try to record a video tomorrow on the electroscope stuff and on gravitational fields and things. I won't be able to record it really until the time that we would meet if we were live. So tomorrow at like 11 o'clock, I'm going to try to record some stuff for the electroscopes and for a quick discussion on fields that will be probably useful and relevant for the work tomorrow. So I apologize, but that won't be, the video probably won't be up as early as they generally are. But I'll try to make sure that the assignment also can be made sense of without that video. All right. Come on, I'm trying to escape. There we go. Any questions on those things there? I'll wait a little bit. This is a spot where if you don't have any questions, I would appreciate just like a no. Thank you so much. One no. Are we doing okay? I'm not going to ask you to turn cameras on. You don't have to talk, but if you just type out a no, this makes sense, or everything's good, or I'm getting used to drinking with straws. I'm not used to that. Huh? With the mask, it's easier to slip that thing in there. Okay, a few folks responding. Thank you, I appreciate it. I just want to make sure that there's nothing too crazy going on. Shoot, and I forgot. There's a way to make it when I do slides. There's a way to make it so you can type questions in anonymously. I'll try to do that in the future. I apologize for not doing that on this one. Okay, and so now hopefully you can see that we're on to the activities and pivot interactives. The thing I want to make sure that you understand, and it looks like a good number of you have already actually done this entire assignment. If you haven't, that's okay. It's not, you know, we get there when we get there. There are some folks that looked at this already. So on this, the reminder, which you might remember from quarter one, or quarter two, first semester, you might remember, you might have forgotten that when you see these sections, you need to click on that little deal to drop down and open up all the questions. This assignment has us using this simulation, and you can do things with the balloon. So you're going to have to end up having two windows open to do that, or two tabs. The thing that I want to make sure you're aware of, I mentioned it in the assignment in Google Classroom, and I think I typed it into the questions here, but opening up the conclusion and summary, there are 5 of these 8, I think, or 10, I don't remember how many ever blanks there are. 5 of them are true. And when you just submit them, if you use up all 9 of your submissions and you don't get all 5 of them true, the software will tell you you got a 0 out of 5. I couldn't find a way to make it like you get for every one correct, you get a point. So the software will tell you you either got all 5 points or you got nothing. But please know that I'll go back through and I'll check to make sure that If you have 4 of them right and you have 1 of them wrong, I'll go through and double check and make sure you get 4 points out of 5 instead of, the big eggshell for uh, having most of it taken care of. Um, all right. So that's a lot of me talking. But I guess in my mind, if we're doing it for a half hour, we can kind of do that, and then you have time to work, and hopefully everything is good. So I hope the notes made a little bit of sense. Um, and you can go back and double check those if you need to double check those. Um, if you have any questions, you can ask. I'll hang on the line here for a few minutes. That's all I have to share with you. Hold on, let's double check and make sure I'm not forgetting. Okay, let's see. So we talked about that. We talked about that. Um, and, so in Google Classroom, if you go to classwork and then view your work, uh, then it will allow you to choose like, hey, what am I missing? What have I turned in and have points for? Those sorts of things. You can check that stuff. Just a reminder for that. So that's all I've got for you. You can hang up and move on. If you have questions, you can hang on the line and stay, and we'll see what we've got. Have a great day, folks. Let me know if you have any
Thank
questions.
you.
Thank you.